Something on it. So we're going to start today right with where we left off yesterday, which is going to be another word problem. All right, over to this next one here. Okay, calculator you're going to need. And again, just be aware of your rounding and that it does impact these answers significantly. So, you know, your answers are going to vary if you go to check them against mine if we round it differently. But if you're in the ballpark, it's okay. So number 1 states that on hole 6, a golfer hits a ball with an initial velocity of 135 feet per second. So this from yesterday is the magnitude of your velocity. And you have an angle equal to 42 degrees, so that is theta with the horizontal. And to begin here, we want to determine to the nearest tenth of a yard. I wanted to give you one more that was like this. How far has the ball traveled horizontally at the end of 2.35 seconds? What do you have to do with this question? Convert it. Yep. So again, I wanted to just give you one more instance that you're going to see that so that you know how to do your conversion. So how many feet in a yard? Yep. So there is so you need to convert this, and I'll write out your formula. So formula for horizontal, and again, you don't need to memorize any of this. So x is equal to the magnitude of your velocity, and you're going to go cos theta t. All right, so your velocity in this case, if we convert it, we're going to just divide it by 3. So I have x would be equal to, I'm going to go 135 over 3. And we're going to go cosine of your angle, which was equivalent to, looking for it, 42 degrees. And your value of time, which was 2.35. All right, all that goes in the calculator. I'm going to check this too because I don't remember how I rounded this. So 135 over 3 and then cosine of 42 and then times 2.35. And this is equivalent. So we have x is equal to about 78.588, and this would be written in yards. So this one is established in yards because I don't think your next one is. Your next one doesn't say anything about that, so you can go back to just your feet. Okay, so letter B. Now how far vertically has the ball traveled after 2.35 seconds? And I didn't have you do this one to the nearest yard, so you don't need to use that converted answer anymore. So formula for vertical. So you're going to go y is equal to, and we're going to go magnitude of your velocity, and you're going to go sine instead, theta t plus 1/2 times your gravitational constant, and then t squared plus your initial height if you have one. Again, it's always assumed to be 0 if you don't have anything stated there. I don't see anything stated on this one. Nope, so that we're going to just plug in a 0. So I'm going to go y is equal to magnitude, I'm going to go of your velocity 135 because we don't need this one in yards. Sine of 42. Value of time in this case is 2.35 seconds plus 1/2 and gravitational constant. So do you guys remember which one are we going to use for feet? Awesome. Yep, -32. Good. And then you're going to go times squared, which is 2.35. And this is squared, and then again, plus nothing. So if you want to put that there, you can. But again, with questions that have different conversions in them, make sure you label your units. All right, so this one is 135 sine of 42 times 2.35 plus 0.5 times negative 32 times 2.35 squared. All right, I am getting approximately, so y is equal to, I got 123.923, if you round that up. And this one is back in feet. All right, so letter C, how long is the ball going to be in the air for? So if you kind of think about your golfing, so let's get you a little picture, yes. So your ball starts and it's on the ground and then you hit it. And I guess you want to pretend you hit it well. It went up into the air and then came back down. So you're kind of doing one of these. All right, so that's asking you to find the roots of a quadratic equation. So yesterday, I think I showed you one that factors. We'll see if this one factors as well. Otherwise, you got to do quadratic formula. So this type of scenario is either going to be your factoring, or if you have to, quadratic formula. And I think your textbook homework, I think you do have to do quadratic formula. It's no harder. It's just, you got to be careful with all those sign functions and know that those answers do get thrown off if you round too much. Okay, so I have y is equal to, we have 135, and we're going to go sine 42t, because we're going to solve for t. And then this right here, 1/2 of negative 32 is just minus 16t squared. And again, plus 0, you can choose to write it or not. So it's up to you. You can do a GCF on this one again. That's probably your fastest bet. Or if you want, you could do this with quadratic formula. But if you did quadratic formula, remember that this is your A term, and then this is going to be your B term. And by the B, what you would use is just literally this entire coefficient right here. So this would go into your formula just to keep it, accurate. Okay. So what do we want to do on this one? Factor or quadratic formula? What do you guys prefer? Factor? Yep, it's faster. So I'm going to take out just a t, just to isolate that. And then we've got 135 sine 42. And I'm going to also take out a 16t like this. And that allows me to get that my first answer is just 0. So this one occurs at a time value of 0. And then my other one, I'm going to go 135 sine of 42 minus 16t equal to 0. So add that one over, and then you're going to take this and divide it. But again, your quadratic formula will give you the same two roots. Doesn't matter. This one's faster to just do like this because it's possible. So divide by 16 and round accordingly. All right, so we have 135 times the sine of 42 degrees divided by 16 gives me an answer of approximately, so t is equivalent to, I don't know, like 5.65 seconds. Was it seconds? Yes. So how long was the ball in the air? 5.65 seconds. How do we feel on that type? Okay. Good. Yep. So again, when you've got the quadratic, you can do your factoring if possible, or you can do quadratic formula. Just remember, if you see one that's quadratic formula, this is going to be your A coefficient, and then this would be your B. And in this case, C would be nothing. So I'll put C right there, but that would be just 0. So you would literally plug that into the formula as a 0, not a 1. Okay. One more word problem, and then we'll do some chapter 8 review. So next projectile question, you have a rocket that is launched at an angle of 70 degrees. Okay, so start defining all your variables. Here is your theta. With the horizontal, and it has an initial velocity of 80 feet per second. So this is the magnitude of my velocity. Again, always going to be a positive value. And how long is it going to take for the rocket to be horizontally 8 feet from the starting point? So this in your formula is going to get plugged in on the left-hand side where X is. So your formula for horizontal. So horizontal is X is equal to magnitude of your velocity, cos theta t. And again, you're going to be able to sub in for at least 3 of these items. How long will it take? Means you are solving this for t. That's what we're looking for. So there's all 4 items right here. So I have 8 on the left-hand side equal to magnitude was, looking for it, 80. And then we're going to go cosine of 70 t. And then you're going to take this and divide the 80 cos 70 expression over. So divide by 80 cos 70 and divide by 80 cos 70. And I'm going to keep all of these rounded to 3 decimal places. So take that, divide it over. 8 divided by 80 cos 70, enter. I got my time value was approximately 0.292. You guys in agreement? Okay, and that is in seconds. So this would be labeled in seconds. Good. All right, so letter B. After 0.5 seconds, how far has the rocket traveled horizontally? So now we're going to sub back in. So horizontal equation is going to be X equals the magnitude of your velocity and then cos theta t. So I don't know this, the other side now. And velocity was, I'm looking for it, 80. And we have cosine, angle was 70. And after 0.5 seconds gets plugged in right here. Okay. You guys getting comfortable with which equation to use one? Good. All right, so we have 80 cos 70 and times 0.5. I got like 13 and change. So horizontal distance in this capacity is 13.681. So we're doing all the rounding the same. This was in feet. Okay. And then your last part of this question, what is the maximum height? Okay, what did we do with that yesterday? What do you need to calculate with maximum height? Derivative, very good. Yep, so you're going to do the derivative of the y equals equation to find the time that this occurs at. So derivative of your vertical equation, y equals, I think that's shorter to right, to find the time it occurs at. Then what you're going to do is sub that value back into the original. So sub into original, not the derivative. All right, so my y equals equation, we have not written yet, so we're going to start with that one. So y is equal to the magnitude of the velocity, and then sine theta t, plus 1/2 times my gravitational constant multiplied by time squared, plus my initial height, which I told you was 0 again. A lot of them are 0. So you have y is equal to, magnitude of velocity was 80. And we're going to go sine 70t plus 1/2. And gravitational constant for this one, are we in feet again? I don't see it anywhere. It's up at the top, I think. We are in, yes, feet. So this is going to be another -32. t squared plus nothing. All right, before you take the derivative, obviously you want to clean up the 1/2 times the -32. So we're going to go y equals first, and we're going to have 80 sine 70 t minus 16t squared, and I'm not going to rewrite the 0. Now you're going to find your derivative. So derivative of my y equals vertical equation is 80 sine 70, because just coefficient, minus power down in front, minus 1 off exponent, so 32t. Okay, so you're going to bump your 32t over to the left-hand side and solve. So 32t is equal to 80 sine 70, and divide. Divide by 32, divide by 32. Anyone have this yet? That's okay. I know, it's hard to write and calculate at the same time. So 80 sine of 70 divided by 32 is equivalent to, I got 2.349 seconds. That's when the maximum occurs at. It is not the actual height. So now to find the actual height, you're going to sub it back into the original, which is this line right here. Again, not the derivative, the original. So this is going to get subbed right in. So I am going to go y is equal to, write a little bit small, 80 sine 70 times 2.349 minus 16 times 2.349 squared. I'm sorry, I am out of horizontal space here. Okay, and then that's your last part there. So this is going to represent your answer, which is the maximum height that this occurs at. So 2.349 and minus 16 times 2.349 squared. All right, I got an answer equivalent to y is equal to, you guys get like 88. So somewhere in the ballpark of 88.302. And this would be expressed in feet. Okay. How are those two word problems? Pretty good? Awesome. So then we're going to move into just everything that we're reviewing from your chapter 8 content. So let me have you pull that formula sheet next. And you do fix something because there's a very slight error to this. On your formula sheets, do you see the box that says parametric equations of a line? You guys see that? It says x equals t a sub 1 plus x sub 1. And then what it needs to say is y equals t a sub 2 y sub 1. So can you change that, please? I'll write that up here. So on your formula sheet, where it says parametric equations of a line, the one that says y equals needs to be t times a sub 2 plus y1. It's when you just distribute them. You know, like I showed you just a way to do it with arrows instead, which is easier than using your formula sheet. But again, just in case. All right, so here's all your questions that kind of pertain to what you're tested on with chapter 8. So number 3 says find the ordered pair that represents the vector from C to D. So this is your formula that you did back on your quiz. You guys remember doing x2 minus x1? And y2 minus y1. So this is equal to x2 was 4. And minus x1 is 2. And then y2 was 12. And then minus -3. Or you can just immediately switch that if you'd like. So the ordered pair that represents the vector is going to be equivalent to 2, comma, 15. Okay, so just like that. Then you're going to find the magnitude. How did we find the magnitude? You remember back? Yep, square them underneath the radical. Yeah, I know it's been a while because it carried over break, so just to make sure. So this is equal to the square root of 4 and 225, which is equivalent to the square root of 229. And I told you did not need to simplify that if it was even possible. How's that type? Do you guys still remember those? Wonderful. All right, so number 4, for these points, find an ordered triple that represents vector EF. So it's really the same type of formula as number 3 above. You're just going to add the z's onto this. So this is 3-dimensional instead. So my formula is going to be x2 minus x1. And then I'm going to go y2 minus y1. And I'm going to go z2 minus z1. Okay. And then you're going to sub them all in. So this is equivalent to x2 is -1 minus 9. And then next I have y2, so this is going to be 5 minus 8. And then next you have 11 minus 5. Okay. So this notation is what's referred to as an ordered triple. So the ordered triple notation is going to be a -10, a -3, and a 6. And again, with notational things, just make sure you're typing these in the correct format. So this is what we call ordered triple notation. So if the question specifies to type it as an ordered triple, this is what you're looking at. Now letter B says to write it as the sum of unit vectors instead. Did yours print with 2 vectors over it? I'm sorry. Or is it just one? Okay, that's what it should have been. It looks kind of weird on mine up here. That's weird. I didn't think yours printed that badly. So as the sum of unit vectors, what you're going to do instead is we're going to go -10. So it's -10i. That's better. So this is going to be -10i. And then minus the 3j. And then plus the 6k. You guys understand the difference with the notational aspect? Okay. Yep, just pay attention to things like that, please. So number 5 says to find the dot product and determine if the vectors are perpendicular. So this is another formula. So formula for your dot product. And anytime you're testing perpendicular is x1, x2 plus y1, y2. So this is going to bring us to -8 times 4.5 plus 2 times 18. Well, this is 36. Actually, this is -36, right? Does it work? You guys remember? It does work, yes. So this is a sum of 0. So you're going to say, yes, these are perpendicular. So this is 0. So we're going to say, yes, perpendicular, since sum equals 0. How's that type? Still good? Good. Number 6 is a cross product question. And this is, again, what you did on your quiz prior to leaving for break. So to do the cross product, this is your determinant again. So you're going to set up the determinant matrix. Again, it's just been a couple weeks, so kind of want to make sure everything was still okay and good. So I go I, and then negative j, and then little k. And then I'm going to place these ordered triples in here. Why does it keep doing that? I'm sorry, let me fix that. It's like distorted. So I'm going to rewrite this as 5, 2, negative 1. So I have 5, and then 2, and then negative 1. Other side is going to be 2, negative 4, and negative 4. And then you're going to go and find all of these again. So this is equivalent to, so I have I, and then my matrix for my determinant here would be the numbers 2, negative 4, negative 1, and negative 4 again, minus the j, and I'm going to have 5 and 2, and then negative 1 and negative 4, plus the little k, and then I'm going to be left with a 5, 2, 2, and negative 4. All right, so just like that. These just take a while. I don't think they're terribly difficult, just lengthy. So I have I, and now we're going to do product of the major diagonal here first. I have 2 times negative 4, which is equivalent to negative 8, minus negative 4 times negative 1 is 4, minus j, and then I've got a negative 20, minus negative 2 becomes plus k, and then I've got a negative 20 minus 4. And again, just pay attention to how these answers are going to get typed in. This one I didn't specify, so I'll give you both. So this would give me a negative 12i, and then plus, because double negative, this would be negative 18 times the j would be plus 18j. And then my last one here would be a negative 24, so I would go minus 24k. And again, this is the notation that you're going to utilize when it asks you to list your answer as unit vectors. If it then says to write them as ordered triples, you're just going to take it one more step and go negative 12, comma 18, comma negative 24. And that is called ordered triple notation instead. Okay. So again, just pay attention to things like that. All right, how are those? Still good? Perfect. All right, your next type. This is your force question. All right, so we have one force of 100 newtons acting on an object. So here's your object. Force of 100 newtons. Then I have another force of 80 newtons acting on the same object. So like that. The angle between the two forces is equivalent to 40 degrees. So that's this angle here. Please remember that that is not assumed to be bisected unless there's something in the problem that states otherwise. Find the magnitude of the resultant force. So what do I draw for a resultant force? Yep, line in the middle, very good. Yep, so this is going to be my diagonal. So your diagonal. So I'm going to kind of, I'll do this first because it's sometimes easier. And then here's my diagonal. That forms my resultant force. You're going to use all those geometric concepts again to build your parallelogram. So in a parallelogram, opposite sides are congruent. And consecutive interior angles are supplementary. So this means that this is 140. And again, that is the angle that you need to use because you cannot assume that the 40 is bisected. So the magnitude of the resultant force is going to be where I denote this with a letter, we'll go X. So right there. So again, if it kind of helps you to consolidate this a bit, you can pull off just one of those triangles and you're going to choose one of your rules to solve for the resultant force. All right, so this is equivalent to 80, 100, 140. Magnitude of resultant force is unknown. Okay, do you guys remember which rule this one is? Law of cosines, yep. That's okay. Yep, this one's law of cosines because it's side, angle, side. Side, angle, side. You have law of cosines written on another formula sheet too. I don't know. If you want to add it to this one, you can. There's space on the bottom, isn't there? Yeah, if you want to go a squared equals, then you don't have to kind of flip through your folder for multiple sheets. So b squared plus c squared minus 2bc cos A. Or if you staple them all together or something, I'm not sure, whatever works better for you. So in this capacity, I'm going to go x squared equals, and doesn't matter which one we do first here. So I'll go 80 squared plus 100 squared minus 2 times 80 times 100. Oh, I wrote too big, I'm sorry. And then cosine of 140. All right, so x squared equals something. So that all goes in your calculator. I'm going to give you this answer first. And then, again, you got to be careful with your rounding on multiple part questions like this. My x squared value was 28,656.711109. And then you're going to square root that. And I get an answer of 169.2829. 321. This is the answer that you have to continue with in part B, okay? But when it gives you the little box to type, you can obviously round it at that point. All right, and this would be in newtons. All right, so now on to letter B. Letter B, find the angle formed between the larger force and the resultant force. Larger meets the resultant, I'll put a Y there. And that's what we're going to find down below. Okay, so since you've already established and used law of cosines, what can you use instead here that's faster? Yeah, law of sines, good. So next you're going to go law of sines. And again, if you want to add this on your formula sheet right now, you're welcome to. So law of sines is A over sine of A equal to B over sine of B. And again, just don't use the rounded answers because they will most likely, you know, mark your answer incorrect because there's too much rounding that's taken place. All right, so in this question, I'm going to go, little a is our resultant we just found. So 169.2829.321 divided by the sine of 140 degrees equal to little b, which was 80 over the sine of y. And you're going to utilize this to solve for your missing angle. You're going to cross multiply and solve. So I have 80 sine of 140 equal to 169.2829 321 sine y. So you're going to divide this over and you're going to second sign this. So inverse sign in your calculator. 282931 divided over. So 169.2829321. Enough to cramp your arm up for sure. All right, so you have 80 sine of 140 divided by, just keep using the up in your calculator, it's way faster. And then we're going to second sign your decimal. And I get an angle here of approximately like 17.68. Okay, and just round accordingly. That would be your second solution there. Okay, how do we feel with the force questions? Pretty good? Awesome. Again, just make a note to yourself too. Don't use a rounded answer for part B, okay? So don't round, just because it double impacts your overall result, okay? It's the only thing I really foresee, you know, anyone having trouble with and just forgetting. Okay, so your last items here, because we already did the word problems, are your vector equations, parametric equations, and slope-intercept form. Okay, number 8. If I'm not mistaken, the vector equation is on your formula sheet. Is it? Yes, I was going to say it's that first equation right there. So vector equation is parallel to vector A here. So I'm going to go x minus x1, comma, y minus y1 equal to A multiplied by T1 and, or do I have that backwards? Yep, I do that all the time. I'm sorry. It doesn't matter. I always put the numbers in the right place, but it's trying to remember that notation. So we do a T first. I always think alphabetical, but it's not. A1 comma A2. There we go. All right, so to write your vector equation, all you're going to do is sub in. So again, this is your x1. This is your y1. This is your A1. And this is your A2. And you just place them in here, and then you have to stop. You don't want to go any further with this. So I'm going to have x plus 2, comma, y minus 1 equal to, I have t, which I'm going to leave as is, and then a sub 1 is 3, and a sub 2 is negative 4. That's it, done. Okay, so you didn't have to write the parametrics. That's when you distribute it. But that's it, that's done. And again, make sure you're typing in that order with a lowercase t. But just know that programs are really picky with things like that. Number 9, same thing. And I wanted to point this out because I saw this on some textbook homework. You want to make sure that these are in a certain order, again, because I fear that your answers are going to get marked wrong if they're not. So to write this in parametric form, you're going to start and you're going to state that x equals t. Please do that first. And please do it in that order. Don't do t equals x. I don't think it can handle that. And then your second equation is going to be y equals. And we're going to go 3t minus 8. So again, can you guys please make a note to type it in this order? Put the t first and the constant second. Okay? So t first, constant second, just because I don't want to see that get marked wrong on you. So t first and constant second. Don't go negative 8 plus 3t. I mean, you can try, but well, I'd prefer if you just didn't, I guess. And then last, number 10. So write the equation of a line in slope-intercept form given these two equations. So these are your two parametrics. So what you want to do on this particular type is we want to solve these both for t equals and set them equal to each other. So your procedure is to solve for t equals. You are going to go and solve for t equals. Then set equal to each other. Set equal to each other. Your final answer needs to be written in slope-intercept form, which is y equals mx plus b, and I'm going to point that out again too. Make sure that you put the x first, just because I don't want to see that get marked wrong on you. So I'm going to take both of these equations and solve them for t equals. So first equation is x is equal to 2t plus 3. So I would have x minus 3 equal to 2t, divide by 2, divide by 2, and your first equation is t equals x minus 3 over 2. Next equation you're going to solve as well. So I would have y equals t minus 4 and solve for t equals again. So I'm going to have y plus 4 equal to t. Next, you're going to take this expression equal to this expression and manipulate it to solve for y equals. So just a lot of algebraic work, essentially. So I'm going to have an x minus 3 over 2 equal to y plus 4. Cross multiply, solve, manipulate it for y equals, and rearrange it in its proper form, and then you're done. So I have x minus 3 is equal to, distribute 2y plus 8. And then we're going to solve it for y equals. So to solve for y equals, you want to subtract your 8 over. So I get x minus 11 equal to 2y. And then divide it by 2. Divide it by 2. I think I'm going to just leave it like that. So y is equal to, there's no need to break it up, x minus 11 all over 2. Okay. How do we feel with chapter 8 stuff? Decent? Okay. All right, the time is yours. You've got a review assignment you can get started. You've got a homework assignment you can get started. Homeworks are due by Monday evening, and then test is due Tuesday.